Okay, we're going to be continuing our next section, section 3.1. Let's just review for a second how we have found different types. When we were solving equations, we found different types of answers. Okay, we can come up with answers like, let's say, x equal 2. We saw answers like x equals a negative 5, x equaled half, maybe x equaled 0, okay? So we saw that when we were solving for variables, when we were solving linear equations, we had one unique solution. But then we recall those two special cases. If we were left with 3 equals 3 or negative 5 equals a negative 5, when this happened, we were left with a true statement, and that's when we wrote that x is all real numbers. If we were left with something like 2 equals 0 or negative 3 equals 5, when this was a false statement, that's when you wrote no solution. Okay? Now, in our next chapter, chapter 3, it's going to be all about inequalities. Now, there are going to be several new symbols that we use for inequalities, and I just want to refresh your memory about what those inequality symbols are. Okay? For example, we first have this symbol here. This is the symbol for less than. And if I was to write an inequality statement that would be true using this symbol, we could write that 3 is less than 6. I could write negative 2 is less than 5. I, of course, could write also negative 5 is less than a negative 1. Okay? These three inequality statements are true because the quantity that's on the left side is smaller or less than the quantity that's on the right side. Another inequality symbol would be this one. And of course, this is greater than symbol. And if I wanted to write some statements using the greater than symbol, I could write, let's say, 8 is greater than 2. I could write 2 is greater than a negative 3. I could write negative 3 is greater than a negative 10. And these three inequality statements would also be true because the quantities on the left side are larger than, are greater than the quantities that are on the right side. Another inequality symbol that we sometimes will encounter is this one. And this represents less than or equal to. Okay, by putting a line underneath the less than symbol, that now becomes less than or equal to. And the key is that word or, because one condition or the other condition needs to be true in order for the inequality to be true. For example, we could write 2 is less than or equal to 5, and this would be true. Even though 2 does not equal 5, since 2 is less than 5, this is a true inequality statement. I could write 3 is less than or equal to 3, and this would also be a true inequality statement. Even though 3 is not less than 3, since 3 is equal to 3, this inequality statement is true because of that word or. One or the other condition needs to be satisfied. One last type of inequality symbol that we will encounter, of course, would be greater than or equal to. That's the symbol for greater than or equal to. And for example, I could write 10 is greater than or equal to a negative 3. And that would be true because 10 is greater than the negative 3. I could also write negative 4 is greater than or equal to negative 4 because this would also be true because of the inequality statement involving the or equal to symbol. Even though negative 4 is not greater than negative 4, negative 4 equals negative 4, and only one of the conditions needs to be satisfied. Another thing that I need to show you before we get actually into solving the inequalities is how we write our answers when we involve variables. For example, if x is, let's say, less than the number 2, this is how we represent the inequality algebraically. We can also represent it, you may recall, on a number line. On our number line, the number line goes on forever, whether it be a negative infinity or a positive infinity. This is the symbol for infinity, which means the numbers go on forever. To represent this solution, and there are an infinite number of solutions because any number that is less than 2 would make this inequality true, recall how do we represent this? Well, we put the critical number 2 on our number line. Now, the number 2 itself is not an actual solution, but all the numbers less than 2 are part of the solution. So since 2 is not actually a solution, we represent it with an open circle. Now, as far as the numbers that are less than 2, well, we have either the left side or the right side of the number 2. And we should know from past experiences that numbers that are less than 2 would fall here on the left side of the number line. So this is how we would represent the shading, okay? This shaded part of the number line represents all the numbers that x could possibly be, okay? Now there's one other way that we can express this inequality solution. It's with a special kind of notation, and it's called interval notation. And interval notation is something that we will be using a lot. Okay? Now, to represent the interval, the range of solutions, you start with the smaller quantity. Now, this is going towards a negative infinity. We put a comma, and then after the smaller quantity, we have to put the larger quantity, which happens to be the number 2. Now we need to enclose these two quantities. Since we are not actually physically landing on negative infinity because it goes on forever, we use a parenthesis. Once again, as we approach 2, we are not physically landing on the number 2, but we are merely approaching, getting as close as we can to the number 2. Once again, we would have to use a parenthesis. Okay? This is the interval notation that represents this algebraic expression for this inequality as well as the number line. Let's say, for example, we had x is greater than a negative 4. Once again, we want to represent this maybe on the number line. So here's our number line. It goes from a negative infinity to infinity. We would put the negative 4 on our number line. Once again, since negative 4 is not actually part of the solution, we would actually put an open circle. Now we need to represent the numbers that are greater than negative 4 with some shading, and the numbers that are greater than negative 4 lie here to the right of negative 4. Once again, we would want to express our answer, our final answer, using this interval notation. Okay, so the interval notation tells us to start with the smaller quantity, the negative 4, comma. Then we are going to go towards the larger quantity of course, infinity. Since we are approaching the negative 4 is not actually part of the solution, we put a parenthesis. Once again, you never land on infinity because it just keeps on going. We would put a parenthesis. And this would be the interval notation way of expressing this algebraic solution. What if we had x is less than or equal to, let's say, the number 5? We need to be able to represent this on a number line as well as with interval notation. And it's going to be slightly different because now the 5 is actually part of the solution because x could be less than or equal to the number 5. You may recall from a previous math class that if 5 is part of the solution, what we would do is you would shade in the circle on the 5. Okay, you would use a closed circle because if it's shaded in, that means it's part of the solution. Once again, x could also be less than 5, which means we would have to shade to the left of 5. The interval notation that we would now use, remember we are going towards the smaller quantity of negative infinity, comma, the larger quantity, the positive 5. The infinity symbols always have a parenthesis, but now the number 5. Since 5 is actually part of the solution, we have now filled in the dot. We include the number 5. We have to use a different symbol to represent that. We are not going to use a parenthesis. Parentheses involved open circles like the 2 and like the negative 4. But since 5 is part of the solution, we have to use a bracket to represent it. The bracket is the symbolic way of representing 5, or that critical number, being part of the solution. Okay? Of course, let's just do one more. If x was greater than or equal to, let's say, 0, okay? Once again, on the number line, we would put 0, the critical number. We would have to fill in the circle, shade it in because 0 is part of the solution. Also, x could be greater than 0, so we would shade to the right. The interval notation, the smaller quantity is 0, going towards the larger quantity of infinity. Since 0 is part of the solution, once again, we would use a bracket. And since we are going towards infinity, we are merely approaching infinity, parenthesis. Okay? So as far as the interval notation is concerned, if you have a less than or a greater than symbol, you are going to use an open circle on the number line, and you will use a parenthesis when it comes to the interval notation. If you have less than or equal to, greater than or equal to, then when it comes to the number line, you will use a closed circle. And when it comes to the interval notation, you will use a bracket. When it comes to the infinity symbols, whether it be a negative infinity or a positive infinity, it doesn't make a difference. You will always use a parenthesis when it comes to the interval notation. Okay? So that's just a little summary of the different symbols and how we use them in terms of just the number line and the interval notation. But now what we're going to do a great deal in section 3.1 involves those 4 steps that we had when we were solving linear equations. Okay? So here we recall the 4 steps. Except I'm now going to use these same 4 steps when we are solving inequalities. And I'm actually going to add a 5th step. So let's just review them. Step 1. You want to simplify both sides of your inequality. And how do we do that? The distribution property and the combining of like terms. Step 2 is you want to get the variable on one side of your inequality. And for that, we could either add or subtract. Next, in step 3, we are looking to eliminate the constant by either adding or subtracting. In step 4, you're going to eliminate the coefficient by either multiplying or dividing. And now here I'm going to add step 5. Step 5 only applies to solving inequalities. And step 5 says, if you multiply or divide by a negative number, you must flip the inequality symbol. Which means if the symbol initially was less than, you're going to make it greater than. If the original symbol was greater than or equal to, then you're going to flip it and make it less than or equal to. Okay? So step 5 is a new step that applies to only when solving inequalities. Okay? Once again, it says, if you multiply or divide by a negative number, you must flip the inequality symbol. Okay? Very, very important. Let's take a look at some examples. Let's say we have the following. 5x minus 1 is going to be less than 7x plus 9. And we want to solve this inequality. We're going to express it on a number line and ultimately using interval notation. Now, we don't have to worry about step 1 here. We don't have to worry about simplifying either side. There's nothing to distribute, and there are no like terms on either side. Step 2 we will perform because the variable is on both sides. So now let's get the variable on one side. And what I'm going to do, as always, creature of habit that I am going to get my variable x on the left side. And so I will subtract the 7x over. 5x minus the 7x would give us a negative 2x minus 1 on the left. On the right, we are left with the number 9. Step 3, we want to eliminate the constant, which happens to be the number 1. So I'm going to add the number 1 over. That, of course, would give us a negative 2x is now less than the positive 10. We're up to step 4, whereby we want to eliminate the coefficient. To eliminate the coefficient, I am going to divide by the negative 2. On the left side, negative 2 divided by negative 2 is x. On the right side, 10 divided by the negative 2 would give us a negative 5. And now, step 5, we ask ourselves, did we multiply or divide by a negative number? And the answer is yes. We divided by a negative 2. And so what we have to do is flip the inequality symbol. Right now the inequality symbol says less than, but I'm going to flip it. And I'm going to say x is greater than negative 5. So let's represent this on the number line. Here is the negative 5. I'm going to use an open circle because negative 5 is not part of the solution. Greater than negative 5, that occurs to the right. So there's the shading on the number line. Most importantly, though, the interval notation. I am going from negative 5 to infinity. Since negative 5 is not part of the solution, parenthesis, the infinity symbol always uses a parenthesis. So that would be the interval notation that represents your solution. Okay? Let's try another one. Let's say we have the following. Maybe we might have, let's say, 3 times x plus 2 is going to be greater than or equal to 2x minus 5. And we want to, once again, of course, solve this inequality for x. Well, I'm going to perform step 1, in that I will distribute, first of all, the 3. And in doing so, we would get a 3x plus 6 is greater than or equal to 2x minus 5. Step 1 is complete. Step 2, let's get the variable on one side. So I will subtract the 2x over. Now I would have x plus 6 is going to be greater than or equal to the negative 5. Now we have to move on to step 3, whereby we are looking to eliminate the constant. The constant happens to be the number 6. So I will subtract 6 over, giving us, of course, now x is going to be greater than or equal to the negative 11. Well, we don't have to worry about step 4, nor do we have to worry about step 5. We have our solution. X is greater than or equal to a negative 11. Let's represent it using our number line. I'm going to put negative 11 on the number line. We would have to say it's greater than or equal to. So since it's or equal to, we would have to fill in the circle. Where are the numbers that are greater than the negative 11? Once again, they occur to the right. So there's our number line. Finally, now we need to represent this using interval notation. The smaller quantity, negative 11, comma, larger quantity, infinity. But now we have to group these quantities together. Remember, since negative 11 got filled in because it's part of our solution, we have to use a bracket to represent it, and the infinity symbol always gets a parenthesis. Okay? That's an example of solving the inequality. Okay, using similar steps that we did to solving the equation. We just added a 5th step that we sometimes have to use, once again, when we multiply or divide by a negative number. Let's try a few others, maybe even a special case or two. For example, let's say we have 5x minus 3 times x minus 2 is going to be less than 2x plus 9. Once again, now let's go and solve this. I start with step 1. I will have to distribute my negative 3. That would give me a 5x minus 3x plus 6 is less than 2x plus 9. I'm not done with step 1 because I do want to combine like terms. 5x minus the 3x is 2x plus 6 is less than 2x plus 9. So step 1 is done. Let's now move on to step 2. Let's get the variable on one side. So I'm going to subtract 2x over. And now I am left with 6 on the left less than 9 on the right. Now once again here, remember, the directions will ask us to solve for x. Looking at this problem, there isn't any more x's, okay? Just like when we were solving equations and the variable that you were solving for goes away, you have to look at the statement that's left. So here we are left with the statement that 6 is less than 9. You have to ask yourself, is that true or is that false? Well, 6 less than 9, that's true. Okay? So how are we going to represent that, first of all, on our number line? If everything is true, everything from negative infinity to infinity is going to get shaded in. Because basically we are talking about x is once again all real numbers. Every number would work. Every number for x, if I substitute it into my inequality, would always produce a true inequality. Now, how could we represent this using the interval notation? Well, let's take a look at our number line. Our number line goes from negative infinity, everything is shaded in between, to the positive infinity. So our interval notation is going to look just like that. It's going to go from negative infinity to infinity with parentheses around it. This is how we represent using the interval notation of all real numbers. Okay? Let me give you one to try. Once again, try this problem. I'm going to put the problem on the tablet and pause the video, work through it, and once you're done working on it, come back and let's see how you made out. For example, let's say we had 4x minus x minus 7, which is less than 3x plus 4. Try this problem now. Pause the video, and when you're done, come back. Okay. Well, for starters, step 1 tells me I would have to distribute this negative understood 1. So that would give us a 4x minus x plus 7 is less than 3x plus 4. I'm going to still perform step 1, and then I'm going to combine the like terms on the left side. 4x minus x would give you a 3x plus 7 is less than 3x plus 4. Step 1 is done. Step 2, let's get the variable on one side. I will subtract 3x over. And now we are left with, on the left side, the number 7. On the right side, we are left with the number 4. And now, once again, the variable that we are solving for is gone. So we have to look at the statement that remains. Now, 7 is less than 4. Does that make sense? The answer is no. That is a false statement. Okay, so nothing is true here. So as far as our number line is concerned, nothing is going to get shaded in. So basically what we have here is a no solution. So just like equations, okay, as I demonstrated way at the beginning of the lesson, okay, if I could find it, here it is. Okay, when we were solving equations, we had that the variable x equaled a very specific number. Or if we were left with a true statement, that's when we wrote x is all real numbers. If we were left with a false statement, that's when we write no solution. And the same is true, as we just demonstrated, with the inequalities. We use the same steps, okay, and we can get the same type of solutions, okay. We can get x is less than a number, x is greater than a number. If the x cancels out and left with a true statement, that's when you write all real numbers. If the x cancels out and you're left with a false statement, that's when you write no solution, okay. All right, so that completes section 3.1, okay, where we were solving inequalities. We are not done with inequalities just yet, okay? Chapter 3 is all about inequalities, so we're going to be taking a look at them a little bit more, all right? But this is just the foundation, and we're going to be building upon it, as we always do in math class. You're always building upon prior concepts, so we cannot forget the earlier concepts, particularly when we are solving these inequalities. Very important here, okay? These 5 steps, all right? particularly this fifth one, don't forget about that, that if you multiply or divide by a negative number, you must flip the inequality symbol. Okay? All right. So there is some homework problems that go along with section 3.1. Give those a try, and I'll see you next time. Until then, be well.